Okay, so our last outcome is R5, quadratic word problems. So there are a bunch of key types of questions, and you've seen a lot of them already in terms of word problems that can involve quadratics. Most of the time, you're going to be provided with the equation. There are going to be times when you're not. You will have to generate your own equations, and it's really important that you look for evidence in your word problems themselves as to what the variable actually is, and then what are you truly trying to solve for. So before we actually dig into these questions here, I just kind of want to recap. So in terms of what types of things you can be asked to do, we're always going to be looking at solving an equation in some capacity. And so what I want to just remind you of is we've got a number of different strategies for doing that, depending on what we want to solve for. If we're just solving for x, we can do that in a number of ways. So solving for x can involve factoring. It can involve using the square root if we're dealing with vertex form. So factoring can work for general form. Radicals or roots can work if it is in vertex form. We can also use the quadratic equation if it's in general form. Okay, so we've got three strategies just for solving for x. But what about if you are asked to find a maximum or a minimum? Well, where is that actually referring to on your parabola? It's referring to your vertex. So in that sense, you are always going to be solving for your vertex. I personally am going to default then to converting my equation into vertex form by completing the square if I have to. If you don't want to complete the square, you can use the other strategies that we talked about in general form. Okay, so option 1 is to complete the square, to get it in vertex form. Option 2 is to find your x-intercepts and do your average of them. Okay. Or you can use that negative b over 2a to solve for x. Okay, so we've got a number of strategies. If we're then asked for the y value, if we're asked for the height, something like that, then that means that we're implying for the y value. Okay, so there's some key things to kind of watch for in the questions, watch for cues to kind of help you out. Or that sometimes they give you a specific value and then you're just, again, solving for x, going back to using these strategies up here. So let's have a look. And the problems that we're going to look at here are specifically optimization problems. These are super common when it comes to quadratic functions because optimization means that we're trying to maximize or find our kind of best or peak or prime values to work with. Okay, so step 1 is you set up your variables. Step 2 is you set up your quadratic function. Step 3, complete the square. Step 4, find the vertex. The y value is your maximum or minimum. The x value is when it reaches the maximum or minimum. Okay, that horizontal coordinate. So let's give this a shot for example 1. Seth has 50 meters of fencing to enclose a rectangular area. Okay, so we've got a rectangle. The entire distance around needs to be 50 meters. Okay, what's the word that we use to describe if we're traveling around a shape? Remember, it's the perimeter. Okay. Find the maximum area. So remember, area of a rectangle is length times width that can be enclosed. What are the dimensions? So we need to maximize the area and figure out the dimensions. Well, the dimensions are length and width. And we can create an equation based on this perimeter piece to help us out. 2 lengths and 2 widths are going to get us to 50 meters. But we also know that area is length times width. But we need to be able to plug in something so that we can reduce, because right now we have 3 unknowns in this equation. Well, that's not going to help us figure out anything. So we have to simplify it, get rid of one of those variables by substitution. So we're going to use this perimeter equation to actually isolate one of our variables. So if I want to get rid of width, I'm going to isolate it. So it's going to be 50, or actually 25 minus 1 length gives me the width. So I divided everything by 2 to get that 25 and get rid of my coefficients. And then I moved the length over onto the other side. Okay, so width is 25 minus the length. So when I go to fill in my area equation, I can actually describe it as length times, instead of width, width is 25 minus length. If I expand this from here, it's actually going to start to look like a quadratic equation. Yeah, so I'm going to rearrange this. I'm going to complete the square and get it into vertex form. I'm going to factor out the negative. Half of 25 is 12.5, and I'm going to square it. So half of 25 is 12.5. Squared is going to be 156.25. If I've added it in here, I've actually subtracted it because I factored out that negative from the L squared. So I'm going to add it out here, 156.25. So my final answer is going to be, in terms of my equation, L minus 12.5 squared plus 156.25. Okay, well, what does that mean? Well, it means that my vertex is going to be at 12.5 and 156.25. Okay, my input is my length. My output is my area. So I found my maximum area. Maximum area is 156.25 meters squared. My length at this size is going to be 12.5 meters. And my width, I'm going to calculate by plugging that back in here, and it ends up actually being the same, 12.5 meters as well. There we go. Those are my answers. Okay, so by completing the square, I was able to determine my vertex, which actually created my scenario for knowing my maximum. Okay, so that's why that vertex form is so incredibly helpful.